All right, I think we're going to go ahead and get started here. I'd first like to apologize for the technical difficulties there. First off, I'd like to say welcome to today's Altero-sponsored webinar on upcoming features in Hyper-V vNext. My name is Andy Serwich, and I'll kind of be officiating the webinar today, and I'm joined by Aidan Finn and Rick Claus. Hey, guys.
How you doing?
Good afternoon, good evening.
So first off, let's review our agenda for the webinar today. First, we're going to do some introductions of Aidan, Rick, and myself, and we'll also briefly introduce our sponsor, Altero, as well. After that, Aidan and Rick are going to talk about where we are currently with Windows Server 2012 R2 Hyper-V. Then we're going to get into the stuff that everyone is here for, right? The guys are going to talk about all the new stuff that's coming for Hyper-V and its associated technologies in vNext. Following that, we're going to do a brief overview of Altero Hyper-V Backup. Then we're going to wrap things up with some conclusions and Q&A. Now, a couple things to note about the Q&A section. Please hold your questions until the end of the webinar. And also note that some questions may not be answered if that particular answer contains any information that may be covered under our NDA with Microsoft. So keep that in mind. Now that we've covered our agenda, I'll go ahead and move on to the introductions. Aidan, how about we start with you?
Sure. I'm at Joe_Elway on Twitter, and I'm a Hyper-V MVP like Andy. I work for an Irish distributor of technology called Micro Warehouse at www.mwh.ie. And I've been working since '96 in all sorts of different roles, working in Microsoft infrastructure, server, virtualization. In the last year or so, working with Azure, IaaS. And at night, I do some blogging, some writing. I have aidanfinn.com as my own site, and I'm the contributing editor on Microsoft Virtualization for the Petri IT knowledge base.
Thanks, Aidan. And next up, we've got Rick. Hey, Rick, would you like to go ahead and introduce yourself?
I'm Rick Claus, Senior Technical Evangelist over here at Microsoft. I'm based at the mothership at Redmond, Washington right now, and I've been doing Microsoft stuff now for about 10 years working here, and then before that, enterprise consultant, got started in IT as the guy that literally jiggled the cable to get the printer to work. That was probably over 20-odd years ago, but specialized in virtualization, enterprise consulting, and data center architecture stuff for about the last 15 years or so.
All right, sounds good. Thanks, Rick. Next, I'll go ahead and introduce myself. Again, I'm Andy Serwich, and like Aidan, I'm also a Hyper-V MVP. You can catch me on Twitter at @aserwich. During the day, I work as a cloud services engineer for the Trivalent Group, who is a West Michigan-based service provider. I kind of spend my time during the day coming up with solutions to everyday business problems using cloud-based solutions such as Hyper-V and Azure. I'm the lead technical role behind all things Microsoft at Trivalent, and I like to share that expertise with my fellow engineers and our customer base, in addition to the IT community. Also, I spend some of my spare time blogging and publishing materials for the IT community at large on my own site, serwichit.com, and also for Altero's Hyper-V Hub. Next up, I'd like to briefly introduce the sponsor of our webinar today. Altero Software is a fast-growing developer of some really awesome backup software, such as Altero Hyper-V Backup. We're going to cover that in a little bit more detail later on today. So at this point, I'll hand things off to Aidan and Rick so we can get to the stuff that everyone showed up for today. Take it away, guys.
Cool. So what we want to do first is talk about where we are right now and what Microsoft has done to this point, just so we can set the foundation for what Microsoft are going to be doing in vNext. So in the last two versions of Windows Server 2012 and 2012 R2 Hyper-V, Microsoft have taken their enterprise class hypervisor and improved it, added functionality, increased uptime and scalability to the point where scalability isn't really a conversation point anymore. And they've built around it in terms of automation, administration, increased uptime, storage, networking, giving us the ability to build public, private, and hybrid cloud solutions. So with Hyper-V, we have now this huge scalability. If anyone questions the scalability of Hyper-V, then I would say take a look at Azure. You know, last year at TechEd in North America, they were talking about Azure being something like 1 million hosts. Azure is running Hyper-V. So if 1 million hosts isn't scalable enough for you, I start to wonder about what it is you're looking for. how they have reached that scalability, well, they've done that with lots of different things. So they've done things like hardware offloading. So on the networking side, we've got single root I/O virtualization for low latency networking. We've got receive-side scaling to increase non-virtualization networking. We've got DVMQ to increase virtualized networking bandwidth into virtual machines and into the virtual switch. We've got lots of different things there, including RDMA, or Remote Direct Memory Access, which gives us low latency, high throughput storage networking through the SMB3 protocol. So we get that for storing virtual machines, but we also have live migration, which is able to take advantage of that protocol. So now we can live migrate really, really fast. So 10 gig, 40 gig, even 100 gigabits per second live migration over multiple NICs at the same time on networks that we're also using for storage, virtual machine communications, hosts, and clustering and management and backup. So we can do all this lovely converged stuff using the elements or the features of Windows Server without having hardware dependencies. From 2012 to 2012 or 2, we got easier migration because Microsoft realized, we're going to be getting more frequent upgrades. So being able to upgrade our hosts or move our virtual machines from an old host to a new host, that needs to be easier. So we're able to do that with zero downtime to the actual services that are running in the virtual machines. Linux became an equal citizen with Windows Server as a Hyper-V guest OS. So we get a Linux file-based backup. We don't have VSS within the guest OS, but we do get file system consistent backups of Linux virtual machines. And we get dynamic memory support in Linux as well. If you're running in a larger environment, such as a hosting company, we get software-defined networking, or SDN. This is the ability to have software-defined networks and subnets, which are able to have overlapping IP addresses and are completely independent of each other. Where you see an example of that is Azure. When you sign into the Azure portal and you create a network for yourself, you're actually doing software-defined networking. And you can do that with Hyper-V and with System Center in the Windows Azure pack. System Center gives you the ability to scale out and to manage, to do bare metal deployments, to do clever load balancing and monitoring and automation and service delivery, which we can build on with the Windows Azure pack or WAP. So we can build a true self-service cloud, be it for the enterprise or for the hosting company. All of this together, well, we're getting a new way of looking at doing compute, storage, and networking in our rack. You can see a diagram of it here where we've got something called a scale-out file server. You don't see a SAN in the cloud. You see software-defined storage in the cloud. And this is the sort of thing that we've been able to do since Windows Server 2012, and has improved in Windows Server 2012 or 2 using commodity hardware like just a bunch of disks. So we get that huge scalable storage within our rack with the same sort of fault tolerance and performance as you get with a SAN, but at a fraction of the cost. We can then direct some of our budget or redirect some of our budget into getting higher bandwidth networking, and then put in those fantastic Hyper-V hosts, all managed with System Center and deployed with System Center.
I was just going to say, I think what you're seeing basically is you're having a lot of these technologies that we've been developing up in the cloud environment coming down into our on-premises products, and also a lot of the architectures from the best of both worlds kind of coming into play. Like you mentioned, software-defined networking. Basically, you're just kind of described with a scale-out file server, the software-defined storage example as well, coming down and working inside of our environment. So really good times are going on, and kind of gives you a clear idea of where we're going in the future, and also what you can do right now with the stuff that you already have on your on-premises environment.
Yeah, and Microsoft have taken virtualization, and it's no longer we're just virtualizing servers. We're now virtualizing the storage, and we're virtualizing the networking. Because we've gone completely software, or we can go completely software, we can automate, we can improve service delivery, we can make it self-service. And this is all stuff that has pretty much come from the cloud model that we see in Azure, and we're able to bring that now into the enterprise. So that leads us to what Microsoft are doing next. So the next version of Windows Server and System Center we can expect in the calendar year of 2016. Beyond that, we don't have any specifics. But right now, and you have been able to do this since October 1st of last year, you can download a technical preview of Windows Server, and you can start looking at some of the things that we're talking about today. So you can start deploying the next version of Hyper-V, evaluate it, and give feedback to Microsoft. There's a lot of time left until the next version comes out, And I can tell you as an MVP that the product groups involved in Windows Server and System Center are very receptive to feedback, and they love getting feedback. They love it when you're able to tell them, why something needs to change or why something needs to be added, rather than just saying, I want X. If you say, I want X because it's going to make this difference and how it's going to affect the following customer types, then Microsoft love that and they act on that sort of thing. And a lot of what we're talking about has come from that sort of feedback. It's also come from, as Rick said, from Azure, and also what Microsoft has observed in the deployment of Windows Server 2012 or 2, whether it's projects that Microsoft have helped out indirectly, or whether it's been stuff that they've heard about in feedback, or whether it's been stuff that they've seen through support calls. A lot of this has made a lot of changes. So this release is coming pretty hot on the heels in terms of old release schedules after 2012 or 2, but there's a substantial amount in there and there's a lot of significant change. So that leads us to what is coming in vNext. So I've talked about the scale-out file server. It's the ability to take cluster-supported storage, such as a bunch of JBODs or cluster in a box, or even a SAN if you want, and present that through a highly available, continuously available file server cluster, and that has something called transparent failover. Lots of marketing lingo in there, but basically we can have 2 or more Windows file servers clustered together, taking aggregated storage, which could be just a bunch of disks, which gives us the ability to do things like storage spaces with tiered storage with SSDs and HDDs, and write-back cache for absorbing peaks in write demand. And we can present that to servers such as a Hyper-V host over the SMB3 protocol. Now, storage is one of those foundations of virtualization. And as a member of the community, I've seen and heard lots of stories about how storage has either made a virtualization success or a project successful, or it's broken a deployment. And one of the issues in there is performance. We're all worried about IOPS, or at least we should be worried about IOPS. And Microsoft made some improvements in Windows Server 2012 or 2 where we were able to start controlling IOPS a little bit. We had the ability to cap the amount of IOPS going to a particular virtual hard disk or virtual machine. But we could only do warnings about setting minimum levels of IOPS. The minimum level of IOPS is pretty important because that's what defines an SLA, guaranteeing that a machine should get a certain amount of bandwidth through to the disk or disks. We hadn't had that in the past. We're getting that in the scale-out file server in vNext in a feature called Distributed Storage QoS, or Quality of Service. Using a policy manager on the scale-out file server, and right now managed through PowerShell, we can configure policies for tenants, virtual machines, or virtual hard disks to specify a minimum level of IOPS that should be guaranteed, or a maximum level of IOPS that should be obtainable by a virtual hard disk, virtual machine, or a tenant. This allows us to guarantee SLAs. It allows us to share out bandwidth or storage performance on a predictable basis. And in the hosting or service provider world, it also allows you to set price banding. So if a customer pays X, they get a certain number of IOPS. If they pay Y, they get more IOPS. You see that sort of thing in Azure between basic and standard virtual machines. Also, we can use this to start limiting misbehaving virtual machines. So if some machine starts going a bit crazy, its service has gone wonky, someone's written a bad SQL query or something, we can start limiting that damage very, very easily. And this is distributed, so no matter where a virtual machine goes on those hosts, the scale-out file server is still applying the same policy. And that really is improving what we're going to get from this software-defined storage from Microsoft in Windows Server vNext.
I think that the point you mentioned right there about the misbehaving VMs comes into play for most of the customers that aren't on a very large scale size, just to ensure that they have properly behaving VMs. But definitely a common thread you're going to see here is that we're going to be talking about high availability with this concept of clustering throughout this one session, for sure.
Yeah, clustering is a particularly important feature of Windows Server and Hyper-V. It's, in terms of getting high availability and fault tolerance, and there's a lot of things that Microsoft have done with clustering in vNext. It's not just the traditional levels of fault tolerance that we're seeing now. We're seeing softer things being brought in as the technology matures. Speaking of which, Rick?
Yeah, got you there. technical difficulties with screen refreshes here, so I'm listening to the key click of you advancing the slides to know when the slide actually moves.
Okay.
But speaking of clusters, one of the things that was made available in the last little while was the ability to have stretch clusters or multi-site clusters, and was made easier under the last release. But with anything to do with clustering, you have to have this concept of votes that allows you to determine, or the cluster software to determine, if the workloads are in a healthy state or not, and if not, if they have the quorum of votes, they can seize control of it to be able to continue that service. And so in an environment where you had a stretch cluster or a multi-site cluster, you have to think of it as, here's my one side and here's my second side, but if I put my third vote in either of those two sides, it gives them an unfair advantage with regards to calling the shots as to whether or not the service is healthy or the workload is healthy. And so one of the things that we did with the vNext version is we've made the cluster console and the cluster software available to use from a quorum perspective a impartial third vote, which is actually up inside of a cloud environment, as in Azure. And so vNext clusters will basically allow you to support the use of what's known as a cloud witness, where it's as simple as creating a new blob inside of a storage account that you have active in Azure, and then you configure the quorum settings inside the cluster manager or through PowerShell with the proper account name and storage key to be able to write to that blob. And they basically just go through and they increment the number that's in there to say that they're active and working. When a particular fault happens on a different side of that particular issue, the other working cluster will be able to contact the cloud service and the cloud witness to decide if it should have enough votes to be able to take control, and then seize control if required. So this also works as well if there happens to be intermittent Azure outages or Azure issues to get to your account, but for the most part, it gives you a quite simple and elegant solution to the issue of having to maintain a possible third site when you have a stretch cluster.
It's a great improvement, I think, because traditionally, if you were creating a multi-site cluster, you needed that third site where you're putting that file share. But then you're talking about high availability, so best practice in the past would have been actually you need a clustered file server in that third witness site, and to be able to get rid of all that complexity and then the cost of running a third site and a clustered file server, and just say for a few cents a month we can have a file share in Azure, that's a significant improvement, and it's going to make things much easier to deploy.
Yeah, definitely, I do believe so.
Okay, and speaking of dealing with clusters and errors and stuff like that, earlier on I talked about how Microsoft had done things to deal with softer kinds of issues. When we build a Hyper-V infrastructure or any sort of virtualization infrastructure, we try to build very resilient infrastructure solutions. So we try to have multiple switches and fault-tolerant firewalls and teamed NICs and all this good stuff. But the cold hard reality is that no matter how much we invest in storage or networking, bad stuff happens. Sometimes those very expensive NICs have issues. Maybe their firmware wasn't as good as it should have been. Maybe the storage has glitches every now and then. And we've got technology in Windows Server and Hyper-V like failover clustering that can deal with outages. But sometimes the way that we would deal with an outage in the past isn't necessarily the best way to deal with it. So what Microsoft have done is they've started looking at things called transient errors. These are glitches that come and go, and they're dealing with these in different ways. So for example, with storage, sometimes a LUN or a cluster shared volume will disappear briefly. And in the past, that would have caused the virtual machines to panic and crash. And that's obviously a bad thing. Services are going to go offline, administrators are going to panic, and we're going to get stressed out. So instead of that happening at 2 o'clock in the morning and you getting woken up, what Hyper-V will do in vNext is it will pause the IOPS of that virtual machine and pause that virtual machine and wait for that storage to come back. And if the storage comes back in an acceptable amount of time, the virtual machine will continue running. That's much better than actually just saying, heck, let's just crash the virtual machine, fail it over to another node, hope the storage is there, start it up again, and if it doesn't, whoops. Instead, we're waiting for that storage to come back. And that's dealing with a storage transient error. In the clustering world, we have this thing called a heartbeat, where each node in the cluster is heartbeating, and if one of them fails to heartbeat within an acceptable amount of time, it's presumed to be dead, and the virtual machines are failed over, so they stop executing, they move to another host, they boot up, and their services start up. And, for a pretty light virtual machine, that might be 30, 45, 60 seconds. But if it's a big virtual machine with complex services, that could be a bit longer. So if we had some sort of a network glitch, maybe a switch reboots, maybe an operator pulls the wrong network cable from a switch, maybe firmware on a NIC crashes and that causes Heartbeat to fail for whatever reason, and the NetFT driver in Windows Server doesn't have another route to send the Heartbeat, then what would happen right now is there'd be a crash. The virtual machines just fail over. But with vNext, we have cluster compute resiliency, which allows the virtual machines that are on that isolated host that's no longer heartbeating, it allows those virtual machines to continue running. And if the host stays offline for an excessive amount of time, then a failover will actually happen. But if it's only a brief glitch, the virtual machines will continue to run, and when the glitch goes away, the virtual machines are still running. And that will be configurable, so we'll be able to figure out, okay, when should we actually fail over those virtual machines? Now, what happens if there's a lot of glitches? So we've got a flapping switch maybe, or a flapping switch port. Well, in that case, we get something called cluster quarantine. The cluster will quarantine that host that's constantly going into an isolated state. And it will prevent further virtual machines from being placed onto that host, and it will cause the virtual machines that are on that host to be live migrated to the rest of the cluster. And if the host stops flapping within an acceptable amount of time, then it will be pulled out of quarantine. Otherwise, it will stay in quarantine. And that's how Microsoft are going to deal with a lot of those niggly things that can cause panics and crashes when we really don't want them. Yeah, we can detect when the little glitches happen, and we can deal with those, but we don't have to panic as much as we would have in the past. And more cluster improvements, courtesy of Rick.
Yeah, so in case you haven't already caught this thread, clustering is something we're going to be talking about a lot when it comes to Hyper-V and virtualization, but it also applies just in general to your overall infrastructure. So that server rack that we showed you at the very beginning, we were dealing with a cluster for software update, for software-defined storage. We're dealing with cluster, obviously, for virtualization as well. And so one of the things we wanted to do was to make clustering even easier as far as migrating between versions when the new version comes out. And so there's this new concept of doing, based on your feedback, this concept of called cluster OS rolling upgrades, where the idea of all the different components that are part of your private cloud that you're running inside of your data center, inside of your server room, you're going to have the management layer, going to be looking at doing system center and that sort of stuff on top of a high availability cluster. You're going to have your storage on a cluster. You're going to have your compute on a cluster as well. How would you get that upgraded to the next version of vNext when it does happen to come out in its final form? And so we've introduced this new state that's called a mixed OS mode for those clusters. I mean, in the past, it used to have to be that you would either acquire new hardware, build the new version on top of that, and then migrate workloads over, if they're able to be migrated between clusters, to that new environment, which ended up being a little bit cumbersome and a little bit complicated because you'd have to acquire new hardware and new switching capacity. And so instead, what we're proposing now with this concept of mixed OS mode is that you're able to actually go in and move workloads off of one of the nodes of your cluster, provided you have 3, obviously, to be able to make sure you have high availability. And then once it's been moved over, be able to upgrade or clean install that new node, bring it back into the cluster again, and you're now running with the old version plus the new version vNext inside that environment, and then move workloads over to that new box and continue n+1, n+1 until you're complete, and then you can actually switch modes from being mixed mode into final mode. So very cool concept, and it should make it so that your transitions of states between them happens quite smoothly. And the newer functionality, what's going to be available in the vNext side of things, don't actually come into play until all your nodes are going to be updated inside that initial environment. So the next coming slides are coming up here, which I'm going to have to rely on my friend Aidan there to advance the slides. Will actually kind of show the step-by-step process. And I can see here that we have an existing environment where we have your 2012 R2 cluster environment all up and running with all 2012 R2s. Next stage you would go through is you would go in and move the workloads off of one of those nodes, as I mentioned, so that it becomes basically a paused environment, so there's nothing working on the target server that you'll be working on. You then would go through and proceed to remove that particular node from the cluster. Once that guy has been removed, you're able to go through and complete an OS clean install upgrade on this guy, clean install on that particular guy. We're not supporting an in-place upgrade at this point in time because, again, generally our feedback has told us that people prefer clean installs on hardware when they're going between versions for various different reasons and comfort levels. You introduce that server back inside of the 2012 R2 cluster as an additional node, and once it has been inside that particular environment, you're then able to go in and migrate workloads back over to it. This could be a test workload, a test machine to make sure everything is all fine, to make sure that everything is good. You then go through and move workloads over to have one more freed up and one more freed up, one at a time, taking them out and repeating that same process that you had before until everything is complete. And then once everything has been completed, you're then able to go into switch the last stage, which is switching over into the vNext version functional mode of the cluster, and then you're all set to go and upgraded. So relatively painless, no new additional hardware is required provided you have at least 3 nodes inside of your cluster to ensure that you have continuity in case there is anything that goes wrong during that particular migration and upgrade process, and you're good to go for a nice seamless upgrade.
It's certainly a big improvement over what we did in the past, and I think service providers or IT departments that have a service-centric view of how they deliver IT to their employers or their businesses are definitely going to like this. It's certainly a feature that there was a lot of feedback on to the clustering product group, and I think that in early testing it does look like they've done an amazing job for something that is under the covers quite complex.
And so just to be clear about some caveats with regard to this, you obviously cannot introduce any 2012 R2 cluster nodes into the final cluster when it is set up as the vNext version, which is obvious. Once you've made that functional level change, you cannot include any new ones into it. And as you mentioned, it's been definitely something that has been an improvement for being able to work with this.
Okay, speaking of big improvements, we're talking about backup here, and it would be a shame not to talk about some of the great improvements that the Hyper-V group have made in backing up virtual machines. Backup certainly has been one of those things that has caused a lot of issues for people over the years with Hyper-V. When cluster shared volume first came out in 2008 or 2, there were lots of issues there. We saw issues with how hardware vendors dealt with volume shadow copy service and VSS hardware providers. We saw some backup products not really do a great job in supporting Hyper-V, and Microsoft decided that they really needed to invest in backing up Hyper-V to improve the performance and the experience for everybody. Not everybody does as great a job as Altaro at doing backup. So first of the changes that Microsoft did was to start devolving the use of volume shadow copies for volume shadow copy service for backing up virtual machines and move towards a file-based backup that's going to be more scalable and more reliable. VSS is still used within the guest OS if it's supported in that guest OS, so we can get application consistent backups. Now, one of the things that Microsoft wanted to do was get rid of the need for third-party change tracking that's living within the kernel of the management OS. So Microsoft has built in resilient change tracking into vNext of Hyper-V. So this gives backup providers the ability to use Microsoft's own built-in block-based tracking of changes in virtual hard disks, which means they don't have to write their own filter driver to sit in there and track what's happening with the virtual hard disks to do incremental backups. Now this is kept in memory in the host, where it's got a very granular tracking of change, but it's also stored on disk, so if the host reboots or crashes, we still have that change tracking there, so the backup products can still do incremental backups. And then we see how the backup has actually changed. So there's a file-based backup system using a backup checkpoint. So this is what we used to call a snapshot. Now we call them checkpoints. And this allows a live export of the virtual hard disk, and that is used as the backup. And then with the resilient change tracking that Hyper-V is providing, we then can do differential exports. And this takes the changes since the last backup and exports that as a virtual hard disk, and that is our incremental backup of our virtual machines. So now we get a much more reliable backup system that's based on technology that Microsoft provides and builds into the kernel, and that allows backup vendors to be able to keep up with any change that Microsoft introduces much more rapidly. And for customers, hopefully it's going to be a much better experience. And another much asked for feature request was hot add and online resizing.
Yes, this is what I call some of the little niggly small things that we can add in that may not be readily apparent unless you start to dive in a bit more to each of the different functionalities that exist with the vNext currently in technical preview. And so one of them is obviously dynamic memory, where you're able to establish a machine and set it up to use dynamic memory from the start. Now when you're using Windows Server Technical Preview guests, you can also increase and decrease the memory on demand, even if you did not set it up as a dynamic memory from the start when you created that individual machine. And it's also done while it's running as well. So very cool technology to be able to support that, to again allow you to tweak up and tweak down the resources available to a particular machine if it needs to have some more performance, more access to in memory for those particular applications. And then same thing along those lines with some good added benefits is the ability to go through and do a hot add of a network interface cards, provided you're using a Generation 2 VM as the VM guest. So very easy to go through and add additional NICs as required to change your situation and also take them back out again, put them in for teaming purposes or whichever, and then take them out when no longer required for hot add and remove of the NICs. And then this is one I didn't actually think anyone else got bothered by it. I know I was bothered by it myself. It was the ability to go through and individually name the network adapters inside the virtual machine settings and see the exact same name inside the VM guest as well, as opposed to the generic name of network interface adapter number 1, network interface adapter number 2. You can now go through with some PowerShell commandlets to be able to go through and to readily identify the names on the host and have them also represented and visible inside the VM guests as well.
Yeah, I think I was bothered by that one as well. I actually
So it wasn't just me.
No, I actually submitted feedback on that one because
Oh, nice.
like many people, my first experience with scale-out file server was building virtual machines with shared VHDX with lots of NICs. And I didn't know what vNIC was on what network. So I was disconnecting vNICs in the settings to try to identify which NIC in the guest OS was which. And if I'd had this feature, I'd still have a full head of hair.
Oh, nice.
Yeah, they could have saved me a whole lot on Demoxenil. Quick Simpsons reference. And then the online resizing and hot add. If you're in a production environment, just to be able to monitor your systems and say, okay, we need more memory here, or we need less memory, or we need another NIC to increase bandwidth, or whatever, and not have to shut down the workload. I mean, that's more time at home. You're not working out of hours to do this stuff. Those are things that are very admin friendly, I think. And there's lots of change. We've barely touched on the amount of change that's in this next release of Hyper-V. There's significant amounts in there, and with the time that's left until we have the next release, I wouldn't be surprised if we see lots more before RTN. So things like binary virtual machine configuration files. So Microsoft are moving away from the XML format to using binary files. So this is going to allow or give us slightly better performance for virtual machine startup. But what we'll also see is that virtual machine versioning is also supported as well. So when you move a virtual machine, in the scenario Rick was talking about earlier when we're doing the cluster OS rolling upgrade, one of the steps that you'll do at the end of that is actually increase the version of your virtual machine configuration from 2012 or 2 to vNext. Those of you who are using Hyper-V Manager, you're going to be able to connect from your PC to your host using alternative credentials. It's always been considered, or it's been considered for about a decade now, best practice that you have 2 user IDs as an admin. You have your email and browsing ID, and you have your server admin ID to stop browsers or infections by drive-by attack or whatever from getting onto your server network. And Hyper-V Manager is also switching to WinRM as its protocol. The likes of Paul Thurrott and anyone else who's using Windows client Hyper-V on their Surface Pro 3s are going to be delighted to hear that there's going to be support for new power states, including connected standby. This is a big one, I think. Integration component upgrades. How many times have you ever encountered a new feature in Hyper-V, gone to try it, and it didn't work? And then you realized, I forgot to upgrade my integration components. Or you go to move your lovely 2012 or 2 virtual machines to vNext, and you need to upgrade your integration components. Now, there have been lots of hacks to try simplify and automate and make that quicker and stuff like that. Microsoft are actually taking advantage of one of those hacks and have turned it into a real solution. So what we're going to see now is integration components for the guest OS are going to be deployed via Windows Update. So we no longer have to manage that stuff. It's just going to be done for us. All we've got to do is make sure that we're running our SSEM or our WSUS, or the guests are configured to go to an update service, and they will get those updates. And of course, if you use one of those products like SSEM or WSUS, you're going to be able to completely control that, so you can have your change control. A lot of people are using checkpoints, formerly known as Hyper-V snapshots, in ways that Microsoft didn't originally envision, and they've improved checkpoints now to deal with those scenarios. So a lot of people are doing DevOps, and devs are getting in and snapshotting virtual machines and using that as a rollback mechanism, which wasn't really the intention of checkpoints. So now in vNext we have something called production checkpoints, where a virtual machine will be saved with VSS consistency. And when we restore that checkpoint, it's as if we have restored a virtual machine from a backup. RDMA, Remote Direct Memory Access, a fantastic feature. I love it for doing SMB3 and for live migration because it allows me to get low latency and it reduces the impact on my processor. If you've been doing converged networking, so maybe you've got 2 or 4 very large bandwidth NICs on your hosts and you're trying to do everything through those NICs, you haven't been able to do RDMA, which is unfortunate. In vNext, you will be able to. So you'll be able to converge your storage networks and your live migration networks for RDMA through a pair of high-capacity NICs running at 10 or 40 or faster gigabits per second. SMB protocol is being improved again, so we're moving up to SMB 3.11. We're getting negotiated encryption, which is going to be a little bit faster and more efficient, and clients will also be forced to adopt encryption if the server requires it. Right now, the client can actually say, hey, you know what, I'd rather not do encryption. Now we're going to actually force encryption from the scale-out file server if we want to. And then we have virtual machine groups for orchestrated checkpoints. So this is where if we're doing shared VHDX to create a guest cluster, we can group our virtual machines, and when we create a checkpoint, we'll get one consistent checkpoint across all of the virtual machines attached to that shared VHDX. So it's a lot of stuff, and that is just a whistle-stop tour of the many, many features that are in there. These are the ones that we thought we'd call out because we thought they're the most interesting, and probably some of these here haven't gotten a lot of attention yet. Anything else you want to add there, Rick?
I think if you advance the slide one more time, did it go off and give you the URL? There you go. I made that a short form URL just for you, aka.ms/Aiden Awesome Hyper-V Next Post. It just rolls off the tongue. Redirects to this phenomenal person called Aiden Finn, who has created a nice web page that's documenting all the incremental changes and large changes that are happening to the Hyper-V vNext world. And he's also been updating them as he writes more posts and details about each one. So I'm giving yourself some credit on that one, buddy.
All right, good stuff, guys. I really appreciate you taking the time to cover this today. You know, one thing that I find interesting in all of this is that as vNext rolls closer and closer to release, it really seems like the concept of any workload anywhere at any time is really starting to become a reality. What do you guys think?
I think virtualization has just become the norm now, and when we look at the stack that Microsoft has provided, Hyper-V on-premise, Hyper-V in the hosting company, Hyper-V in Azure, it's an amazing solution. And
your skills translate across all three of those too. You manage them basically the same way, right?
Yeah, like I came to Azure having never looked at Azure about a year and a half ago, and it was amazing how much of my Hyper-V knowledge actually applied. And it's not even necessarily that deep of an Hyper-V knowledge that I've needed because Microsoft are looking after the core infrastructure. I'm looking after the provisioning. So I've understood, okay, this is what I need to do for my virtual machines to make them perform well. And a lot of the stuff, it's kind of cool to actually fire up a virtual machine in Azure and poke around in the guest OS settings, and you're able to kind of figure out what the hosts are and stuff because you know that stuff from Hyper-V. It's very cool. And it's great to be able to say, okay, I'm going to deploy something on premise. Maybe I'm going to lift and shift it and move to a hosting company. Maybe I'm going to lift and shift it and put it in Azure. Or I can create a 3-tier application and run it across all 3 of those different clouds. It's just very, very cool. Or, Hyper-V Replica. Be able to have a DOR site that I can afford. And it's not some big capital investment. It's actually an operational cost that's very predictable and it's a low cost. ASR is one of those things that, it's really embraced my market, which is small, medium enterprise. And I love what Microsoft have done with ASR.
Very cool stuff. Really appreciate your insight. So what we'll do now is we'll cover Altero Hyper-V Backup, and then we'll move on to the Q&A section that everyone's waiting for. So Altero Hyper-V Backup, the entire premise of this product is efficiency, ease of use, and simple configuration. And it really shows. You can have backup setup taken care of in as little as 5 clicks. The application works with Server 2012 R2, 2012, and 2008 R2. It also works great on server core machines, so there aren't any concerns or worries there. It also contains some of the more advanced features that we've come to expect in backup applications like granular restores. The program is fully Hyper-V aware, it requires very little resource overhead, and it's cluster and CSV compatible. Plus, it fully supports SMB 3.0 use cases.